lightning, you are a bit too early. That will be tomorrow. But luckily, I've decided that we will do a demonstration concerning pyrotechnics, because it's a subject very dear to my heart. And since you are hackers and computer nerds, there's not very much I can tell you about programming, but maybe the pleasure of being, as we say in the trade, blowing shit up, maybe that will cheer you up. Yeah. Very good. We will get along like the proverbial house on fire. So, to start, all firemen and pyromaniacs alike are familiar with the fire triangle. All of you know the fire triangle. For those of you who don't, the fire triangle basically consists of, states that you need 3 ingredients to make a fire.
Oxygen!
You need an oxidizer, you need a fuel, and you need a source of ignition. So tonight I would like, by means of a number of demonstrations, to play around with fuels and oxidizers and different sources of ignition, and basically illustrate some of the beauty of pyrotechnics, because pyrotechnics is the art of fire, and this is my business. And I would like to show you some of this stuff and tell you to not do this at home, and probably you will, and if you do, be careful. So let's start at the very beginning. I brought with me a couple of fuels, and to start this demonstration I have with me a bottle of propane. Propane is a quite flammable gas with nice energy content. And let's explore some, by means of some demonstrations, ratios of fuel and oxidizers. The oxidizer tonight mainly will be air. Most of you know that air contains about 20% oxygen, which is the reason that we can breathe and live, thankfully, and also makes the art of pyrotechnics so much more interesting. So let's start with the first one, which is, since it's a party, no party is complete without some balloons. So let's start with a balloon filled with propane. I have here a source of ignition. So for the first demonstration, let's fill a balloon with propane and ignite it, and basically see and listen what it does. Are you ready? Yeah. Very good. That went nicely, right? So let's do that again, but this time, well, let's add some more oxidizer. notice any difference? Okay, so let's add more air. So hopefully this illustrates by changing the ratio of the fuel to oxidizer, you can have completely different effects, changing from a bright flame to an explode with, the bright flame with a whoop, very pretty, and with 50-50 mix, a slightly more intense, vigorous flame towards even an explosion with probably slightly bluish. But basically illustrates that the ratio is important, and by playing with the ratio you can change the effect to the desired what you want it to do. But so far we've only used a flame as the source of ignition. So how about if we change the source of ignition and make it much more energetic? So next to me I have an IDM, which stands for Instant Death Machine. It's 420 joules of energy. 50 joules is enough to kill you instantly. This will kill you instantly 8.4 times. So to illustrate this, I have here a 1mm wire, copper wire, and we will charge it up. And copper is not generally considered a good fuel. It does react with oxygen, but let's say we make the source of ignition very intense, and let's see what that does to the copper wire. So here goes. The rubber gloves are not only for the sexiness. It's fully charged. Are you ready? Very impressive. Can we try this again? You think? Yeah. Yeah. Okay. It's pretty charged. I will wear the rubber glove. Let's see what it does. Nope.
No.
So the copper wire does not want to play along tonight, but I have another metal. Let's first make sure it's completely discharged. Let's try some steel wool, which is not generally considered a minute rust. So let's see what that does with an extreme source of ignition. I'm starting to like this rubber glove. Okay, are you ready? Okay, charging. Yeah. Let's see how this goes. Lights. Okay, so iron is a mildly reactive metal, but let's see if we use a really reactive metal, like something you might have in your kitchen, some aluminum foil. Let's see what that does. Okay, so we have some aluminum foil connected.
Shout out to Square Pusher.
Okay.
That's also pretty cool.
Yeah, we have it charged. I will put on the sexy rubber glove. You ready? Lights. Let's try that again. Okay, can we charge it? Okay, we have, let's try it again. Oh, that's better. Okay, so that's a couple of reactive metals. But most of you have probably heard of thermite. So how about, and generally thermite is quite an exothermic reaction, but it's quite slow. But let's see what it does with such a nice extreme source of ignition. I have here, if I can find it, a drinking straw filled with some thermite. And let's hook this sucker up. I think
Yeah, we do.
yeah. Okay. Let's do the rubber glove. We have power. Yeah. Charging. That should be enough. Lights. You ready? It like that. It's still going. Okay. Let's discharge it some more. Okay. Okay. So for the last high voltage discharge experiment, I have generally considered not a very good fuel. Very good oxidizer. It's a plaster of Paris, which is used by model makers. all over the world. It's considered quite an inert material. And we mix it with a bit of aluminum to make it conductive. Let's see what this does with an extreme source of ignition. Play along. Okay, it's in there. I think it makes contact. Okay. Are you ready? Let's charge this sucker up. I have the rubber glove. Power, please. Yes, there we go. Nice. Full. I'll give it a no. Okay, lights. Are you ready? Camera. It was less impressive than I had hoped, but it worked. That's the first time you've seen plaster of Paris burn, haven't you? Well, that's the first time I've seen it burn as well. Okay, so this basically shows that by changing the source of ignition, you can do some pretty interesting things with strange fuels and oxidizers. But pyrotechnics is I mean, it's more than just explosions, and I say this even though I like the explosions. But one of the most beautiful reactions is the reaction of steel with air, especially if you can get it nice and hot. So for my next demonstration, I have a small welding machine hooked up to a carbon arc and a small tube filled with cast iron. And well, let's see what that does. For this, I have to put down the microphone and get dressed a bit more safely. No rubber gloves this time, some leather.
That is serious business.
Yeah. It's fine. Safety square. I don't even want to look at it. I don't want to look at it.
So we've reached the end of my short presentation. But before we end, there is one more, and it's basically my favorite of all fuel and oxidizer mixtures. It's a famous mixture called black powder. And black powder is, as the name states, a black powder. I have a small amount of it here, and I will pour it. We'll pour some here onto the. That's about a big teaspoon. Let's add a bit more. Can never have enough. Fuck it. So that's a very big teaspoon. So what do you think is going to happen? Okay, make your bets. Lights.
No, not bang.
Ooh, so, but the real power of black powder is not unconfined. The real magic of black powder happens when you compress it a little bit and you let it build up some pressure. That's when the magic happens. And with this, I will put some ear protection. And behind me, I have what is lovingly called a thunder mug. In the days before, let's say, telegraphs and Morse code, the way to speak to your friends over long distances was to ignite well-confined black powder charges to let your friends know that you are still alive. So let's see if people can know that we are still alive. I have behind me a small amount of like a teaspoon, like half of what I was igniting here. And let's see how that goes. I hope, thank you very much for coming out. Enjoy the festivities. For those of you on the side, maybe it would be good to put the fingers in the ears. Are you ready?